Okay, so we're continuing with distance along a latitude. Okay, so we're dealing with distance along a latitude, that is the Earth. Of course, these are two longitudes. Okay, so we're dealing with distance along the latitude. So that is A. Actually, that is C. Let's use other letters. We are using F way too much. So that is C. This point is point C here. This is point D. Okay. So this longitude is 35 east. Okay. And then this one is the 16 west. Okay. -20°. This latitude is 20° south, and then the one on top it's 20° north. Okay, 20° north. And then the question is, find the distance. Find the distance C to D or CD along the latitude. Along the latitude 20° north. Okay, 20° north in kilometers. So you remember, when it's in kilometers, you have now mastered the R. Once it's in kilometers, you remember R. R is going to be what? 6370. You remember the R is going to be 6370. I think you remember that. 6370. That's what the R is going to be, 6370. Okay. So, because it's in kilometers. So, what's the formula? Distance along CD is going to be equal to theta over 3 sec, since it's along a latitude, 2 pi radius cos latitude. Cos latitude. That's at the end. Latitude. That's what's written at the end. Latitude. So what do you have? What is my theta? You remember my theta is that formula, the formula that I taught you. SSDA. You remember it? When you're finding the angle. When you're trying to find the angle, it's SSDA. Okay? This is a calculation. Remember how do you find the angle? Since because of space, I'll find the angle from here. But you know, this calculation should be on the right. So theta is going to be equal to what? This calculation is on the right, eh? I think you understand what I'm trying to say. There's no space here. So what is the angle? You remember I told you how to get the angle? We're looking for the distance CD. C to D. This means horizontal distance along the latitude. So it means I'm using what? What longitude am I using? I'm using this one, which is 16, and this one, which is 35. So it means, what signs do they have? CD, it means it's W and E. So what signs do they have? Are they same signs? E and W, are they same signs? No, different signs. And you say different signs, you what? You add. I think you remember this. Different signs, you add. So I come there. That means I'm supposed to add 16 plus 35 to find the angle, which I'm supposed to use. 16 plus 35. So it would be 16 plus 35, which would be 6 plus 5 is 11, 4, 51, right? 16 plus 35, I'm sure it's 51. So you put in 51 over 360 times 2 times pi 3.142 times radius 6370 cos C. What's the latitude that I'm using where both angles are lying? What's the latitude? It's 20. You see the latitude where both of them are lying is this one. They are lying on latitude 20. All of them, C and D, they are all along this latitude 20. The latitude where they are lying is 20. So I put 20 there at the end. I put 20 at the end of the formula. The latitude where they are lying is on 20. When you punch this on the calculator, the answer you get, that's the answer that you're looking for in meters. Okay? In meters. That's how you calculate. So you first write SSDA, you find the angle which is theta. So CD is lying on 16, and then C is lying on 16, D is lying on 35. They had different signs. And different signs you add. That's why you added 16 plus 35. I think I explained this in the first lectures. So when you multiply this, that's the answer you get. That is what you're looking for.